I'm very excited to introduce Jackie Sheppard. She's going to be sharing with us tonight about a breakthrough in medical history. And we are going to be talking about many things tonight, but I'm going to just share a little bit about Jackie first. She's a wife and a mom and a grandmother. I have had the privilege of working with her now for almost 3 years. Jackie has 50 years of experience in brain health research. Started many years ago.
Started when she was 10.
Yeah, she was 10. Jackie has started schools, and she has also was the principal of a school that focused on special needs teens. She'll share more of that. And she and her husband have traveled the world, and they have a heart to help those that are wherever they are in life. And her passion is to help people get well. And so I'm very excited to turn it over to Jackie Sheppard and let her start sharing this wonderful knowledge with us.
Thank you, Christy. And do you have it on record?
I do.
Wonderful. Where I wanted to start tonight is I want to talk for just a minute on how much we've seen the world change. When I'm looking at your pictures, I see some of you are quite young. I see others that are getting on up in years like I am. I just had my 75th birthday. And when I look back on when I started teaching in 1964, we just did not have the problems with learning and behavior that we had by the time we were in the 70s, 80s, 90s, and of course nothing even then to compare with what we have now. So that's been one of the changes we're all aware of. You're all aware of the emergence of almost an epidemic of diseases like Parkinson's, Alzheimer's, dementia, multiple sclerosis, neurodegenerative disorders, as well as so many people struggling with addictive disorders, alcoholism, drugs. We actually, now it's considered a national emergency that we have so many seniors who are addicted to opioids. So we've watched a lot of changes from the time that most of us started this journey into adulthood. But one of the biggest changes that have occurred is the amount of knowledge and information that you can acquire within seconds. When we got the internet and then we got Google, we could get into research papers and into information that we had never been able to access before. Right now, if I put you all at your computers and I said, go to Google, and I put you on a website called Pub, that's P-U-B, like Paul, U, Bob, Med, Mother, Edward, Dog.gov, G-O-V. If I put you on that website and I started telling you to look up various clinical trials, within seconds, you yourself, right in front of your computer, would be able to read the same clinical trials that your doctor is reading. In fact, many of you are now accessing information before your doctors know about it. What I'm going to be talking to you about tonight, you're going to hear about in 5 years to a decade. It will be common knowledge. Just like when we got antibiotics, people didn't know what antibiotics were. And then everybody was talking about antioxidants and antibiotics and all of these new health terms that have come about in the last 60 or 70 years. But no doctor, no psychiatrist, no sociologist, no psychologist has the time to read all of the research that's coming in every day. David and Christy and I spend a lot of time on PubMed.gov, and every time we get on there's so many new clinical trials. They're coming from all over the world. And in order to have a clinical trial on this particular website, pubmed.gov, which is the National Medical Library and the National Institute of Health, a university has to have 3 peer reviews. So let's say they submit it, and let's say the University of Alabama does a clinical trial. And then let's say that University of Oklahoma repeats that trial. They have to get exactly the same results, no deviation. And then let's say that Vanderbilt University Hospital repeats that trial. If all 3 of them get exactly the same information from their trial, it can be submitted to pubmed.gov. But then of the thousands and thousands and thousands of clinical trials that are submitted, only about 2% are selected for publication. Now, when I was researching my book, and let me see if I can reach this copy, I'm going to hold it up here. When I was researching Silent Takeover, How the Body Hijacks the Mind, I was not only reading clinical trials on PubMed, but I was reading clinical trials from other sites because I wanted the very latest information that I could get on how the body hijacks the mind. I had begun to suspect in the 80s, I was a counselor as well as an educator, when people would come to me for counseling, and I would listen. I had a lot of questions that I asked them, but I began to know that many times when they came to me, their problem had not started in their mind. It was not a psychological problem. In other words, there was a malfunction in their body, just like we were discussing a little bit earlier. So this malfunction in the body began to increasingly change the cells in the body, it eventually led to, maybe it began to lead, first of all, to obsessive thinking. And then maybe it led to depression. And then a lot of times people will go for treatment of depression. And sometimes the medications that they're given can go ahead and cause such a disruption in the brain chemistry that years later they're diagnosed bipolar. So when we go back and unravel some of that, as I do in my book, we find out that, of course, bipolar was formerly called chemically imbalanced and then formerly called manic depression. And back in the early part of the 20th century, the major treatment was lithium. Lithium is a trace mineral. All of us should get enough lithium from our food and our water that we're not manic depressive. So with that information, okay, this is just a trace mineral. Why would some people not, if they're given the same foods, why would they have a deficiency in lithium? Well, that led us, those of us who were scratching our heads going, what's happening here? What are we seeing? We began to deduct, well, it has to be that their gut is not absorbing lithium like the next person's. So that led to a lot of research and a lot of unraveling about the gut. Now it's common knowledge, isn't it? You're hearing all the time about the gut-brain connection. And for so many years, if I was counseling a person with an emotional disorder, it didn't matter if it was schizophrenia, depression, OCD, it didn't matter. When I would get down to the question, there was one question on my questionnaire that said, we didn't used to use the word gut in the South. That was not a word, so we called them digestive issues. And do you have digestive issues? And there's never a time I remember that answer wasn't yes. And so then I would have to very gracefully, with my Southern language, find out what we commonly talk about now. Do you have irritable bowel syndrome, or do you have problems with constipation? And I got where I could almost predict what they were going to tell me. Well, we didn't know at the time what we know now. More serotonin is made in the gut than any other place in the body. So if your gut is in a mess, it doesn't matter if your problems are irregularity or irritable bowel, it's the same thing. You're not going to be able to produce adequate serotonin to make you get up in the morning and feel like the world's a wonderful place. So it has been so rewarding to me to be able to help people understand they didn't have a psychological problem. And in the church, it's been wonderful for me to explain to them, you didn't have a sin problem. It was not a lack of forgiveness, it was your gut. Now, can a lack of forgiveness affect your gut? Of course. But when I was working on Silent Takeover, How the Body Hijacks the Mind, I intentionally wanted to talk about what's wrong in the body. I was led into this research by a research pediatrician who asked me one day, what did I think was wrong with these kids that had ADD, ADHD, and autism? Did I think they were better diagnoses, or did I think we had more children with those disorders? I said, no, we have more children with these disorders. So he said, well, Ms. Sheppard is a teacher. What do you think it is? And I said, Dr. Murray, I think there's something wrong in their bodies that affects their minds. And he said, I do too. And then he said, will you help me? Now, how is a humble little teacher going to help a research physician? He actually needed test animals. And even though my field was teaching high school students at that particular time, I had a tutorial program for elementary school kids who were having problems learning to read. And so we began working together with the parents who would take their children to him. We did metabolic testing. We would test for vitamin and mineral deficiencies. And sometimes the mineral deficiency was lithium. A lot of times there was a mineral deficiency with zinc. Now again, every person in America should have a plenteous amount of zinc. But if you're not absorbing zinc, if you're eating things with zinc and it's going right through your body, you're going to be deficient in zinc. So he would tell the mother, okay, go to the drugstore, go somewhere. We didn't have health food stores on every corner in the 80s. And he would say, buy a bottle that has 40 milligrams of zinc and start giving it to your child every day. Well, when we would test them, maybe 60 days, 90 days later, and I could tell teaching them, I definitely saw improvements. But as their zinc went up, their copper level came down. Then we'd have to add copper. You see, you don't want to give a multivitamin. Now follow this carefully. You don't want to give a multivitamin to a person who already has too much zinc or too much copper. Are you following me? So we didn't do the shotgun approach. It was very selective. Whatever that deficiency was on that blood test is what the child got. But the problem was we were always having a handful of vitamins and minerals they had to take. Instead of taking a 1 a day, they were taking 6 or 8 to balance them. And we could not keep them balanced. We were also testing amino acids. Now, if you remember from school, you eat your food. The food has amino acids, produces amino acids. These amino acids are your precursors for your neurotransmitters. And if you're like, okay, I forgot what neurotransmitters are, these are the chemicals in your brain that really make you who you are. For example, if you're not making enough dopamine, you're going to most likely get Parkinson's. If you have too much dopamine, you may be ADHD. So it's actually these chemicals up here in your brain that when they're working balanced and properly, you have a well-balanced functioning mind. But when you don't, and it's not a choice anyone makes. So if you know someone that's suffering with mental illness, emotional illness, even addictive disorder, we're going to talk about that in a minute, or ADD, ADHD, or autism, they didn't make a choice. This has nothing to do with any thinking or psychological thing they did. So you go tell them tomorrow I said so. It bothers me intently that they've carried this weight of guilt and shame. Instead, something was wrong with their body. So with what we're going to sort of shift to now that I hope that we have established that a vitamin, a mineral, an amino acid malfunction, you see, we couldn't test neurotransmitters years ago. We couldn't put a needle in and test neurotransmitters. Now we can test neurotransmitters in a 24-hour urine test. We can tell if a person's not making too much serotonin or if they're not making enough dopamine. We can tell if their GABA is too low or their glutamate's too high. Problem is when you start trying to put these into the body, you can run into all sorts of other problems. Just as we see with Paxil, Prozac, Zoloft, Wellbutrin, all sorts of things, all of these psychotropic behavior modification drugs. And I asked a psychiatrist recently, he was talking to me about his own son who was struggling. And I said, Doctor, have you ever seen anyone cured of a mental or emotional illness or ADD, ADHD, or autism with the medications you prescribe? He said, of course not, Miss Sheppard. These can't be cured. And I said, I beg to differ. Because if we change what's going on in the body, we will change what's going on in the mind. So you all have the same opportunity I do to get on Google and start researching. But first of all, I'm going to tell you about probably the most, well, I'm not the only one. Washington State University says that this discovery of how to access a signaling pathway in your body is quite possibly one of the greatest medical breakthroughs in medical history. So, Christy, how about bringing up that little Nrf2 diagram for me? Now, in the 50s, it was discovered that cells communicate with cells. Damaged DNA signals, I'm damaged, I'm damaged, I'm damaged. The other cells are supposed to get that signal, and they are supposed to supply what the damaged DNA needs to be repaired. We actually do have a perfect machine. However, if that signaling is weak and it's not happening, the cellular repair will not occur the way it is intended to do. Let's do the Nrf2, Christy. And so what happens is that when the cells are not communicating, I'm damaged, and the other cells are coming, we have a breakdown in cellular repair. In the 1990s, a Japanese scientist began to research how does this work in the body, and he determined with a lot of research that was actually between the plasma and the cells, there was a protein transcription factor that did the signaling, and that the strength of that activation determined the repair. Were you able to find that little Nrf2, Christy? She's going to share screen and let me talk you through it. I think, yeah, here we go. Okay. Here we go. Can all of you see that?
Yes.
Okay, let's move it over just a little bit more. Let's see, can we move that any? All right, now this, you heard me using this term Nrf2. Now this is a very long word that scientists actually call Nrf2. You notice it's a biochemical wake-up call. In fact, we refer to it as the body's watchdog. Now, all of your cells in your body have these little cup-like things on them. And when your nutrients come along, this little cell says, ooh, come on in. And we're going to get back and talk about addiction in a minute and some of the neurotransmitter problems, and we'll talk some more about this, but these are the little cells. Well, what happens with the Nrf2 activator called protandem, which is the one that is what the pharmaceutical companies are trying to actually create their own Nrf2. We have already a Nrf2 drug for relapse in multiple sclerosis. Unfortunately, it causes some pretty serious side effects and costs between $45 and $55. $45 and $55,000 a year to take it. Okay, so here comes the little 5 phytonutrients in protandem, these little herbs at a synergistic formula. And when it comes bouncing around, look what happens. It fits perfectly into that little cell's receptor. And then go ahead, Christy, and make it do its little trick here. So it fits in there. And then this kinase cycle activates the Nrf1 cycle. And notice what happens to this little Nrf2 that is docked on every cell in your body. Watch what happens.
Hey, Papa.
Isn't that amazing? That Nrf2 activation goes right into the DNA in your body. And what does it do there? Well, one of the first things it does is it upregulates survival genes. Your survival genes, can we all jump on mute real quick? I'm hearing a delightful little child's voice. And we'll unmute you in just a little while. So when the Nrf2 gets right in that DNA, it begins to upregulate survival genes. Now, your survival genes have a job to do, and that is to keep you alive, but it's also to keep you well. So it's going to upregulate between 3,000 and over 6,000 survival genes. But the other important thing it does is you'll notice over here that it's the master regulator of antioxidant expression. Just keep that in mind, even if you're thinking, whatever is she talking about, I'm going to clear it up for you. And notice that it has the function of regulating the genome. So what is this actually going to do? It's going to fix stuff that's broken. And it doesn't matter which cell it's broken in. You can go ahead, Christy, we'll come back to the other one in just a minute. It doesn't matter where that cell is that's broken. It could be in your brain, your liver, your kidneys, it won't matter. This Nrf2 activation will begin trying to correct it. Now, Christy, show me that other little Nrf2 slide for just a minute. And then I'm going to put this together real quickly for you. We're gonna do our best. See if I knew how to do this stuff, but I don't. Okay. Well, let's see if we can get that. All right. This is another one showing the human cell and the DNA, and this Nrf2 activator, again, is going to go right in that little cup. This one doesn't move around, does it, Christy? Now, see this little Nrf2, it's docked. It does. Every cell in your body has Nrf2. Now, the Medical College of Georgia says if you can activate Nrf2, you can improve Parkinson's. There are 23 studies on PubMed.gov explaining how protandem activates this Nrf2 response in your body, improving heart disease, cancers that grow tumors, preventing scar tissue, on and on and on. But the ones that are the most exciting to me is a study that says, you can go back to full screen, Christy, that Nrf2 activation causes your body to make more antioxidant enzymes. Now, why is that so important? When you are a child, you will make a self-regulating amount of antioxidant enzymes. But if you have ADD, ADHD, or autism, you won't, or any childhood disease. You will not make enough antioxidant enzymes. Now, one of the most important, actually the most important of those antioxidant enzymes is an enzyme called glutathione. In 2011, Dr. Martha Herbert, who is most likely the leading physician researcher in the United States, maybe in the world, she's at Harvard, she's a physician as well as a scientist and researcher. She said in the summer of 2011 that she is now convinced that low production of this enzyme, glutathione, is the link to ADD, ADHD, and autism. She says, in fact, I'm so convinced I'm going to get a glutathione t-shirt. So what's the significance of that? Well, when you test people with bipolar, depression, schizophrenia, ADD, ADHD, autism, Parkinson's, MS, Alzheimer's, and addictions, as well as fibromyalgia, chronic fatigue, and so forth, typically they will show one thing. They're going to show several things, but one of the major things is low production of glutathione. They're simply not making enough. Geneticists are saying now that over half of Americans are not making enough glutathione. They're saying that half of us are predisposed to not making enough glutathione. So when we were a child, maybe we had enough, but since everyone declines 10% every decade, by the time people hit their 30s, 40s, 50s, and 60s, they are 30, 40, 60% low in the production of glutathione. A child with ADD, ADHD, autism, or anyone with a mental or emotional disorder, their decline would have started much earlier. Now, if you want to check my research, you can get my book off of Amazon and look at all the footnotes. And I only touched literally the hem of the garment on it. So how does Protandim, this Nrf2 activation, how does it increase your production of glutathione? Clinical trials, which you can read on PubMed.gov, says that by activating the Nrf2 pathway, the body gets the signal. The cells actually get the signal. This cell needs more glutathione, and thus body make more glutathione. Now, every cell in your body has to have glutathione, and every cell in your body makes it. But the organ that uses the most is the brain. Clinical trials on Protandim, the Nrf2 activator, the nutraceutical phytonutrient that we've been talking about, and clinical trials will increase the body's production of the body's own glutathione by threefold, by 300%. Now, taking glutathione, we've known about deficiencies in glutathione, so they tried to create oral glutathione injections as well as IVs. Problem is that when you try to put glutathione into your body, even as an IV, we have lotions with glutathione in it for autistic children trying to get it in their body. The body will digest it. You don't want to take glutathione. You want to activate your body or your child's body to make more glutathione. That's how we're designed. And at the same time, this Nrf2 activation in your body will cause free radicals in your body. After this presentation, you can look up the word free radical. It will cause free radicals, which the accumulation of free radicals is called oxidative stress, to begin to decline. After 30 days of taking this, the oxidative stress in your body will have declined an average of 40% in 120 days. Tests indicate that could be as high as 70%. So, how did I find out about this? And then we're going to come back and talk about addictions. I found out about it because I had 45 years of research. I was seeing a chiropractor for a very bad back. She knew that I was working on a book on ADD, ADHD, and autism. We talked about it every time I got to the office. She had 2 little boys. She wanted to ask me questions. She called me one morning and said, Mrs. Sheppard, University of Colorado has developed a nutraceutical that's in research at one of the universities for ADD, ADHD, and autism. They're having promising results. Can you come to the office? And I said, I'm on my way. She said, I have the investigative report. Can you come to the office? If you've had 45 years of research, you want to go see, could this be a new development? You'll be able to watch that. I'll have Christy and David to give you a link so that you can watch it. I saw it. I saw that one little pill that had 5 herbs, synergistic formula, was able to do things that we had thought impossible. Maybe we didn't think it was impossible. Maybe we just knew nothing was doing it. There was not an answer. And so I started taking it. I was also suffering from short-term memory loss. Now, 2 things. When you have a bad back injury and you've had 5 years of debilitating pain, you have high oxidative stress. You have accumulation of free radicals at that injury. You need superoxide dismutase to reduce the inflammation and the swelling. When that happens, that little trapped nerve can go ahead and do what it was designed to do, so the pain goes away. At least it did for me. But I had low production of glutathione. Now, did I know it? Absolutely not. I didn't know it. However, in 6 months, when my brain began to start operating back like it did when I was 40, I began to jump into the research and try to figure out what was going on. At the same time, the moms that I was calling and telling them, put Josh on this put him on this nutraceutical. It's not going to hurt him. No side effects. Only costs $40. Bottle of 30. Call me. Let me know what happens. So I had moms calling me, and I had grown adults calling me because most of my kids that I taught were grown, and they were like, Miss Sheppard, this is amazing. My brain fog's gone. I can think clearly. I'm working right now with a young woman in her 40s. I've known her since she was 7 or 8. She just started taking this. She called me. She said, my brain fog is gone, and I'm happier. I explained to her it was the increasing glutathione. So this is the reason that we want everyone to know about this. And your doctor will know about it within 5 to 10 years, unless you tell him first. You want to let people know that such a product exists, especially if you're working with children with ADD, ADHD, and autism, or you know of people with mental, emotional, and addictive disorders. I'm going to take about 5 minutes to talk about addiction. Christy, how about bringing up that neurotransmitter image for me? Now, you've heard, most of you know that if a child is exposed to lead, they will most likely have learning and behavior problems, right? Do this if you know this. We also hear a lot about aluminum. We hear about mercury. We hear about heavy metals. We also hear about drugs, and we hear about drugs like cocaine plus street drugs, but there's also prescription medications that we take. Maybe we take them for pain, maybe we take them for digestive issues. But whatever you take, if you put it in your body, rub it on your skin, smell it, any way you get something into your body has to decide what to do with it. It's got to decide, okay, I can use this, and something else that may go, oh, I don't have any use for this, I need to excrete it. But what happens to things that come into your body that the body doesn't know what to do with? For example, iron is a metal, right? If you ingest iron in its liquid form or in a soluble form, your body knows what to do with iron. It says, okay, let's make some red blood cells. The same thing is true with zinc. Your body knows what to do with zinc, but your body has no idea what to do with lead and mercury. So it begins to go, okay, where am I going to store this stuff? Now, it must be that we have a lot of empty space in the brain because so many heavy metals tend to store in the brain. And where do they store? Well, they store right here. Remember those little cups? I told you that all of these little cells, everything in your body has little cell receptors. So over here, we have these little vesicles. Maybe they've got serotonin stored. Maybe they have dopamine. Maybe they have glutamate. Maybe they have GABA. But they're stored over here. And so they get a command. They get the response, okay, drop your serotonin. Body got to have some serotonin. And you notice that this little serotonin was able to fit. This little serotonin was able to fit. Sounds like I'm doing the Three Little Pigs. This one, however, was blocked. Now, what was it blocked with? It can be blocked with way too many things. So when it's blocked, what happens to this serotonin? It can't. It bounces. And then it's trying to go back and do a reuptake. That's what these medications do. Well, it gets over here and it's blocked here. And so this little serotonin's trying to go back because it's got to go in a receptor. So what happens if you have a lot of these blocked? You're going to have a problem with serotonin. Even if you make it, you're not going to be able to efficiently use it. That is true of all of your neurotransmitters. But your foundational neurotransmitter is glutamate. If you look it up, I want you to get on the computer when you get off. I want you guys to stay up for 3 to 6 hours tonight checking to make sure what I told you is exactly right. When your glutamate receptors are blocked, which they can be blocked with all sorts of things, including sugar. Sugar can help block them. You don't have enough, you won't be able to have a balance of GABA. Now, if your glutamate is too high, and these things are bouncing over here, it can't fit into receptors, the child will tend to be ADHD. We say that your glutamate makes you think, oh, I can jump off this cliff on my motorcycle and land on the other side. Now, the GABA in the brain, what its job is as a neurotransmitter is it goes, don't be stupid. So when we're working with these children and they are extreme risk takers, we tend to have some adrenal glands that aren't functioning properly, but we also have glutamate receptors that are blocked. When someone is producing too much GABA, they may be ADHD. Or an inefficiency of glutamate and GABA can have the ADD, ADHD child, and especially the autistic child. So what do? Let's say that we've got a lot of these receptors for glutamate. Let's say they're blocked. Well, if you have enough glutathione, guess what will happen? If you have sore muscles, you have a buildup of lactic acid, right? You work out or something, you work in the garden, you're so sore you can't move the next day, and it's lactic acid. Well, it's your glutathione that gets rid of lactic acid. The second stage of liver detoxification, you have to have glutathione for that. Same thing for your kidneys. But the organ that uses the most, as I told you, is the brain. And what does it do in the brain? It has the most amazing ability to go in here and bond with whatever this is blocking and it begins to lift it out, where it then puts it in contact with another enzyme, catalase, which does a beautiful thing. It converts it to a liquid that your brain, when you're sleeping at night, the cerebral spinal fluid can get that out of your body. You have to go to sleep every night so that your cells can repair. So what happens to an addict? Let's say that his receptors have been blocked with nicotine or cocaine or any sorts of drug. Maybe they've been blocked with Ritalin. Maybe they've been blocked with Adderall. We don't know what all's blocked. And he begins to take this nutraceutical Nrf2 activation, and his body begins to make 300% more glutathione. What's it going to do? It's going to come clean them out. And the amazing thing about your glutamate receptors is that when you are making and utilizing glutamate successfully, you will not crave. You won't crave nicotine. You won't crave alcohol. Now, you may still have to give up going to the places that make you want to drink if you're trying to quit. You won't even crave sugar and carbohydrates. So some of you right now are thinking, this sounds too good to be true. But I told you where you can go and find the research to back it up. I also told you at the very beginning, we are now learning things in our living room, at our computers, and on our cell phones that doctors don't know. You're finding out things. Well, let's take example when something horrible happens in America. If you're on your computer, you know it quite often as soon as maybe the people in the area know it. Sometimes you're hearing it before. When people are texting in an emergency, you know it before the police know it. The world has changed. You have all the information you need to change the lives of people around you, and we're building a team that will help you do that. Now we're going to stop for questions and answers.